Good evening, sir. Uh, we'll wait for a minute for everyone to join. Uh, yeah. Everyone, please, I have a request. Can you all please switch on the camera for a minute? We'll click pictures and then we'll start. Uh, Hello, I'll repeat. Can we switch on the cameras for a minute? Then we'll click pictures and then we'll start. Thank you, everyone. We'll start now then. Good evening, everyone. Good evening, everyone. I am Preetha Chaudhary, and it is a great pleasure to welcome you all to the third day of National Level Faculty Development Program on Advanced Statistical Techniques for Academic Excellence in Data Analytics, organized by the Department of Statistics and Data Science here at Christ University, Yeshwanthpur campus. This event aims to enhance our understanding of advanced statistical methods and their application in the field of data analytics. Today, we have the distinct privilege of welcoming Dr. Varun Agiwal, a prominent senior lecturer at the Indian Institute of Public Health, Hyderabad. Dr. Agiwal brings with him over 5 years of invaluable teaching experience, during which he has carved out a niche for himself in the domains of health based biostatistics, big data analytics, statistical modeling, and time series analysis. His passion for education and research is evident not only through his extensive teaching, but also in his remarkable academic contributions, having authored an impressive 60 publications that span various facets of his expertise. This prolific output has earned him two international travel grants, recognizing his significant contributions to the field of public health and statistics. Dr. Agiwal is well versed in a variety of analytical tools, including MS Excel, Stata, EpiInfo, and R. His proficiency in these applications enhances his capability as a distinguished expert in statistical modeling, enabling him to provide insights that are both practical and impactful. Currently, Dr. Agiwal is engaged in several noteworthy research projects that underline his commitment to advancing public health. Among these initiatives are the Operational Research in Capacity Building SEVA project, which focuses on enhancing operational efficiencies in health systems and the Indian health outcomes. Public Health and Economic Studies, conducted in collaboration with the LV Prasad Eye Institute and the Indian Institute of Management, Ahmedabad. Additionally, he is involved in the Medicity project at the Institute of Medical Sciences and the Experience to Evidence project in partnership with Pfizer. These projects not only showcase his expertise but also his dedication to utilizing research as a means of improving public health outcomes and capacity building efforts. Today, Dr. Agiwal will lead us in a session titled Introduction to Time Series Analysis, a pivotal area in data analytics that is widely applicable across various industries, including healthcare, finance, and environmental studies. Please join me in welcoming Dr. Varun Agiwal. Over to you, sir.
Yeah. Thanks, Preeta. Thanks for the organizer to give me the opportunity. I am audible.
Yes, sir, you are.
Yes, sir, you are audible, sir.
Yeah, thanks. Thanks for giving me the opportunity to deliver one topic regarding the time series analysis. So, shall I start my session? Uh, the PPT is visible.
Yes, sir, it is visible.
Yes, sir, it is visual.
The topic for today's session is understanding time series data and forecasting. As the previous research person, Professor Vishnuvardan and Dr. Sikas discussed the regression modeling and the generalized linear models. Now today, but this generalized linear model and regression model, what is the basic thing you have to understand from the regression modeling? That means based on the regression, what do you learn from the this type of model? What data is required? What type of assumption is applicable for doing the any type of regression model? Can anyone can say regarding any assumptions regarding regression model? Some assumptions, for example, linear regression model, independency, normality assumptions. These are the basic
Yes,
assumptions. Yes.
yes, sir. Good evening, sir.
Hello.
Sir, some assumptions like response variable should follow normality, error
Sir.
should do independent to each other,
Correct.
homoscedasticity,
So there are so many
and
certain
like this.
assumptions are there. My more important assumptions is here is the independency. The data are independent. Observations are independent in the regression models, which we discussed in your previous session. Many statistical regression models related to data which are independent because this is a major assumption in any regression model, which we always say is key observation. That means the patient one information and the patient two informations are completely independent. We can disclose the information for the patient one to patient two. That means there is no relationship. There is no correlation between a one patient to another patient. That means independency occur in the regression model. But some particular situation like in time series, what is there? In time series situation where the observations are related. That means the observations is always dependency. Dependency we always seen in the time series database, which is more discussed in the next lectures. The second thing is the forecasting. If you heard in the regression model, they don't use the terminology forecasting. They use the terminology prediction. What do you mean by the prediction? Any participate telling what do you mean by prediction?
So, is prediction and forecasting is same thing? I think.
Okay. Any other? What do you mean by the prediction? If you understand,
Predict the future values
yeah, predict the future value based on some judgment
based on
probability, because when we go for a regression model, we always think regarding the probability, think regarding the association, key how much we have to consider because the regression is defined in terms of the variables, whatever variable, because the variable characteristic is always random. For example, one patient came to a hospital. Okay, this person having a heart attack disease is there, sugar level is high, so many conditions are there. This condition is different for the another person, so that means the uncertainty is more occurring in this type of database. So that we can go for the prediction. That means we have to calculate, estimate the probability of getting this type of disease, this type of patients. So prediction and forecasting both are different. The prediction means they basically refers to making a judgment probability about the future event, because both having a future, because basically your prediction is depend upon the characteristics of your outcome variable, what type of characteristics may be there. But in the forecasting, we have to estimate the future outcome based on the previous historical database. We always discuss the database which is already available. That means the dependency in the observation. For example, right now weather is very different now. Weather daily, the weather forecasting changes frequently. For example, a person look at the sky. Okay, today the weather is very cool, sometimes sunny. Okay, dark clouds is there, for example. So he may give the prediction. He may give the prediction means he may based on the some output. He uh, clouds are dark. Okay, there is some changes in the weather. So he may predict in next few hours there is a rain. There is a rain is happening, because they not use any type of database. Okay, but if someone, for example, someone having a database for the meteorological database last 10 years, last 5 year database. So based on this, that means there's some available historical databases available. Based on this historical database, we have to do the forecasting. So there's a difference between the prediction and forecasting, which we discussed in the time series modeling. So regression is basically use the terminology prediction, but for time series database we always discuss the forecasting. Forecasting is based on the historical database, but the prediction is basically gives us some judgment, some belief regarding the probability, what is happening in the future, that we have to predict. So my learning objective for the today's session is to understand the fundamental of time series, including trends, seasonality, stationarity, to build, evaluate that, utilize the time series model for accurate forecasting, to learn how to apply time series technique across various domains, then to apply the ability to perform time series analysis and forecasting by utilizing the R software. Let's come to the case scenario first. A health researcher wants to study the relationship between the exercise habit and body mass index. They conduct a survey involving 1,000 participants from various demographics like age, gender, economic level. What do you understand this case scenario? What is the objective for this case scenario? Whenever you have to go for any type of research, first we have to identify what is the objective of this study, this case. So if you see, the study shows that we have to identify the relationship between the exercise habit and the body mass index. That means we have to find some relationship, some association, some correlation between the two variables. If it looks, they involve participants. Participate, that means one participant is independent to the another participant, independent to the third party. That means there is some independency occur between the participants. So here, what type of model you should apply? That means here the independence. That means the first assumption, the second, one of the assumptions for the regression model is suitable for here. That means the first the observations are independent, which is the applicability here. So we have to go for some regression type of models in the case scenario one. But if you go for a second case scenario, a retailer manager wants to track the sales performance for their store over a time. They collected sales data at the end of each month for 5 consecutive years. That means they have to calculate the information of sales for every month over the 5 years. So what is happening? They recorded the informations. That means the manager is wants to analysis what type of analysis they want to perform. How does sales is go upward, downward, a constant sale is there over an entire 5 years. So what is happening? Their sell performance. The sell performance in a positive direction, it may be negative direction. That means we have to identify some trend. What type of trend is coming? Trend may be the positive trend, negative trend, constant. What is happening for this? Or this sales, that means it is also depend upon the what type of variables it may. Or sometimes, for example, sales. For example, woolen sale is now happening in this winter season. So there is a high demand for the woolen clothes in the winter as compared to another seasons. That means there's some another seasonal effect is there, which is happening during this there. So time series analysis allows times to make forecasts and develop strategy based on the past performance, because we have to find out the what is the past performance, what the performance last 5 years, so that we have to forecast based on the past information or to develop new strategy to increase the sales performance in future. So you have to understand the case scenario 1 and case scenario 2, where we apply regression model, what type of scenario, what type of applications we have to use to discuss for case 1 and the case 2. Now we have to come to the why time series. What is the use for time series? You have to discuss the regression model. You have to discuss the general linear regression model. What is the drawback for the regression model? What is the drawback for the general linear regression model? There are some certain assumptions always there. Every model, any statistical model, it may be the survival model also, it may be the probability model also, it may be the time series model also, it may be regression model. Every model having a certain assumptions. Based on the certain assumption, we have to fit this type of model for a particular database. So why time series? Because the time series is very important. If you see time, that means always one variable is always your time. Time is a major component apart from the other outcome variable. For example, observation. For example, in the previous example, sales, number of sales in every month. So sales is your one variable. So two variables are there. One is a time. Second is the observations. What type of observations we have to calculate it. So if you see here, so what type of underlying train the systematic pattern? That means first objective is to understand what type of train of your database is, what type of pattern it is followed. For example, train, it may be the upward direction, downward direction, increasing, decreasing. So many patterns you can see like this systematic pattern. That means the systematic, it is something a constant pattern, or it may be the cubic, not normal, as discussed in the generalized regression model. Like this, some pattern is a same pattern is repeated after a certain time of period. So we have to discuss what type of pattern it may be followed. So we have to use the time series, then experiment data inside, because the trend is coming, pattern is changes based on the different time period. That means something is happening in your database. What type of database? Data may be changes based on the some other factors. For example, I say again I should consider that this month Diwali vacations, because Diwali vacation is a holiday vacation, so there is a more demand for the or more shopping during this Diwali vacation. So there is a high demand for this. That means the train is changes here in during the Diwali holidays. Same if you see the woolen again, the systematic pattern, that means seasonal effect is occurred. This that means we have to identify, we have to investigate what type of insight, what type of factors is affected to change your train, your pattern, or your time series. So we have to discuss why time series. Then inference about probability model. As already discussed, so many probability models are available. A lot of probability models are there. But what we do, we cannot go for all models. What is the basic step we follow for any model is first we have to fit the model. Then based on the fitting model, we get the some estimated value of your characteristics, estimated value of your population characteristics. Based on the population estimated value of population characteristics, we have to identify the goodness of fit. Based on goodness of fit, we have to choose which type of model we can use. So similarly here also we have to discuss there are various types of models available in the time series also. Which model is suitable for what type of database? So we have to use the different goodness of fit test, different type of information criteria to select a appropriate model. Then once your model is identified, we have to calculate a confidence interval or hypothesis testing, because these are the major. When we go for any inference, we have to calculate the estimation, we have to go for a confidence interval, and then we go for hypothesis testing to test, because there are certain so many variables are available. Which variables are statistically significant? We have to apply the test to check these variables are statistically significant as compared to others. Once your model is finalized, then we go for the forecasting. That means forecast your future event. We can use certain models which is useful for doing the forecasting, like exponential smoothing, moving average models. So this why time series is very important, because of to understand the time dependent observation, how your time is a one factor which is depend upon the observation. If time is changes, how your structure of your series is changed. So now what is time series? What is time series? A time series is a sequence of data points collected or recorded at a uniform interval. Basically we always having a uniform interval, but sometimes it may be ununiform. Ununiform is also there. That means a balance or unbalance is there. So the structure database enables to analyze the variables over time, to analyze the patterns, trend, seasonal effect, and some other variables which change your structure of your model. So the primary goal of time series analysis is to understand the underlying structure of a data, or to make prediction about future values based on the historical trend. So historical trend, if you see the data is maybe collected in terms of hourly, daily, monthly, yearly, quarterly. So their time component is always there depending on the context of the analysis. Now, how is the time series? How we can go for a time series? First, we have to discuss what is the structure of the time series. Already I discussed structure of the time series having two things. What are data points, that means the observations, or what is time index. That means how your time is reported. Time is reported monthly, quarterly, yearly, or what type of observations made there. So we have to discuss. Then the component of time series. Basically, the component of time series is depend upon the how your data structure is. Data having a trend component, data having a seasonal component, data having a cyclic component. There's some irregular random component is there. So there majorly four components are exist in time series. Then we have to see the types of time series data. What type of data is available? Because in statistics, we always starting from the data types. What type of data it is? Because based on data type, we have to go for different type of graphics, different type of models, different types of hypothesis testing. So here also we discuss what type of different types of data which is useful for a time series. Like as you heard about the discrete and the continuous database, like this we can go more in detail regarding types of time series data. Methods of time series analysis. What type of methods are available to analyze the time series data? Basically, whenever we have to go for any type of analysis, we have to first describe the information. That means we have to go for some descriptive statistics. That means a descriptive analysis we have to perform. That a descriptive statistics in terms of visualizing your time series information, making a plot, line plot we use to see how your structure is going on. Then we have to apply some different type of time series methods like moving average, exponential smoothing. Okay. Then we have to go, because sometimes because when we go for the component, then the structure is not be constant, not be stable. So we have to making a stable constant. So we have to use some decomposition methods, which is useful to make your time series stay stationary. then we go for the forecast. So there's multiple applications are available in time series in different domains. For example, in economic point of view, basically we have to discuss the monthly data for unemployment, because if you go for a government system, they want to find an annual report for the unemployment rate. That means we have to identify how much labor force is available and how much is required, so that they may fill this information. So based on the time series, they may forecast in future what is the unemployment rate in future. Like this in the GDP, gross domestic product at per capita income. So we have to analyze how your domestic product, gross domestic product is increased at a national level, at a country, at a state level also. We have to compare from the international level for different countries, for different developed countries. So we can visualize how your GDP is going towards with direction. So based on this, we have to use the time series model. Then we go for a finance. Finance is related to the interest rate, daily exchange rate, share price. Because basically, if you discuss the share price, this time share price mostly all are heard about the share price. What is share price? How the share price changes because due to some certain reasons, how the market is changes. So we have to identify the different component which is impact, which is directly utilize or changes your share price. That means here again the time component, because the share price always depend upon the previous information. What type of information is exists. So based on the previous information, or based on some certain explanatory variables. For example, market changes, some other factor, for example, repo rate is changes. So this is also change your share price. If you go for the environmental condition like temperature variation, daily rainfall, extreme weather event like this. So this is some certain event is there which is always depend upon your historical data. Based on the historical database, we are only making a forecast for these type of information. In the health, we go for a COVID-19. You all have about how the COVID-19 is spread. So because this is spread, because this is something as an infectious disease. It is a communicable disease. So it is communication is depend upon the previous information. How many are affected in your day one, which is related to your day two, which is related to a day three. So there is some communication is there between these things, like in dengue outbreak, because these all related to how your informations are connected from one to another type to another type. So there is some dependency exists between the first observation to the second observation. For example, if you see in a figure 1, time series visualization of index of industrial production of India. If you see the pattern of this figure 1 is a increasing trend. That means the trend is going towards to a positive direction. But you see the fluctuation is also there. Some fluctuation is going, but the pattern of fluctuation looks like a similar pattern is there, which is shows that some common pattern is also there. Some systematic pattern we have to visualize from this database. But if you go for the second figure, figure 2, time series visualization of BOP, balance of payment of India, if you see, there is some decreasing trend is happening, but there is no common pattern is observed. Trend is there, but no common pattern is there. So that figure 1, figure 2, having two different type of scenario. One scenario is related to your how your train is changing or what is a common structure is there. In the scenario 2, how your train is changing, but there is no common scenario. So there is some mixing of different type of database, which is we have to visualize how we can deal with different type of database at what situation. So if we go for the component of time series, because this we don't know what type of structure is there from figure 1, what is the structure is there for the. So we have to first identify the different component of time series. So there are 4 components as we discussed in the previous slide: the train, seasonality, cyclic, and irregular. What is trend? Trend is over a long period of time. The trend shows whether the data tends to increase or decrease. As you see in the previous example, the figure one having a increasing trend, but figure two having a decreasing trend. So its trend is referred to the average long-term movement because this trend is always visualized based on the long-term movement. Different section of time shows varying tendency in terms of trend that are increasing, decreasing, stable. Thus, however, upward, downward trend we can observe from the previous example. This is one component we have to discuss in the trend. The second component is the seasonality. Seasonality means regular repeating pattern or cycle. If you see here, there is some common pattern is observed in figure 1. This a common pattern is we can see for every year there is a common pattern is observed apart from somewhere, but so there is some regular pattern is observed. So regular pattern is there within a specific interval for every year. This is a pattern is observed such as monthly, quarterly. That means basically the seasonal effect is for the short time period. This can be used for any type of time series, including individual commodity price, interest rate, exchange rate, and the stock price, where we can see the periodical changes, cyclic. Then we go for a cyclic pattern. The third component of time series is cyclic. Cyclic basically we can see in the long-term business movement, like long-term fluctuation that are not fixed length. There is no fixed length is there. This may be happening over a long period of time, often related to the economic burden in a business proposals. Business company they may see the cyclic variation in your database. After a 5 year, there is a decision is happening during, for example, a COVID time. What is happening? There is some certain decision is coming. So this is downward pattern is observed. There is cyclic changes. For example, during the season, business cycle is usually characterized by a slower growth rate than the before the season started. Then we go for irregular. Irregular means random component, which we cannot predict. Which is we have no control for this component. So it is a random, irregular component that cannot be attributed to trend, seasonality, or cyclic, reflecting unpredictable changes in the database. If you see in this figure, in the first figure, if you see the first, we have to see the train. Train is looks like a long time train component we can use to see what type of train it may be there. So if you see, we can if we plot here, we can make a line so we can see there is some train is there in this database. But when we go for the seasonal component, that means some pattern we can visualize here. So one seasonal pattern is observed for a short period of time. But when we go for the long-term trend with cyclic and seasonal variation, so every season there is some variation. Apart from this, there is a long-term variation is also observed due to the cyclic event. Then next is the randomness. Randomness means there is some randomness. Variability is more if you see somewhere the variability is occurring during this component. So therefore, all component are covered in the figure number 4, which having a train, having a cyclic component, having a seasonal component, and a random component. So once we have to identify this type of different type of time series components are available, how we can deal with, how we can identify, how we can utilize, how we can remove this type of component, because this is making a your time series in a different models. So we have to decompose the time series. That means we have to decompose the different type of component. That means decompose is helping in understanding the underlying pattern, whatever pattern it may be. It will be the some trend is present, some seasonality, cyclic present, some noise are present. So this decompose all the component of your time series or make your series in a stable, stationary way of structure. So there are two types of models are available to decompose your time series. First is your additive model, which is having a component for adding the all component, and the multiplicative models. This is the multiplication of the two models. When we apply additive model, when we apply multiplicative models. So that means the additive decompositions. When the additive decomposition is useful, when the seasonal variation is relatively constant over time. If you see in this figure, your seasonal variation is this type of variation. Every quarterly, there is a variation, there is an upward trend is occur for every year. There is a trend is there, but there is a pattern is seasonality is there. If you see, but the variation between the season, this is almost constant. The difference from here to here to here, from here to here, these are constant. So we look at the this database and see that there is a there is no change in the seasonal difference across the time. That this is constant over the time. So we have to apply the additive decomposition method for this database. But when we go for a multiple decomposition, that means multiple model is useful when the seasonal variation increase over the time. You see in this example, the quarterly earning of per shares is there. The seasonal variation increase. In the starting years, the seasonal variation is very low. After a certain period of time, the variation of the season, if you see the season variation from here is very low, low, a little bit high, then it may increase. But there's a pattern is there. If you see there's a seasonal pattern, you can easily observe for a during a 1 year. But this is increased during the time period. That means it is not be constant. It having an increasing pattern. So we have to apply the multiplicative model. So additive model is applicable when your seasonal variation is constant over the time, but the multiplicative model is applicable when seasonal variation is increased over the time. Once we identify what type of model we have to use, now the next step is to decomposition. How we can decompose your series, how to make your series free from all the component. That means the train component, seasonal component, or cyclic or random component. The first step for decomposition is estimate the trend. That means we have to estimate the trend of this series. For a particular series, we have to estimate the series. So there are multiple ways to estimate the series. Basically, we have to use some basic methods like moving average method, exponential smoothing. These are basic we have to use to estimate the trend. Otherwise, we have to use some type of regression models. Some type of regression models we can use to estimate the trend of your observation. Once you have to estimate the trend, the next step is to retrain your series. For this, we have to this is depend upon the how your data structure is. Data is having a additive model, data having a multiplicative model. If your data is having a additive model, we have to differentiate from the previous information, previous objections. We have to differentiate to get the series free from trend. If your multiplicative model is there, then we have to divide it from the previous observation to make your series free from the trend. Once your series is free from the trend, then we go for a next step is a seasonal effect. There is some seasonal effect exist or not. So the step we have to go for step 1, step 2. If it does not exist, we can not go for a seasonal, we directly go for a random component. So for seasonal effect is always not short term. That means it will be a weekly, quarterly, monthly, to For monthly data, that means we have to estimate the effect for monthly wise. Monthly wise, we have to visualize. Monthly wise, we have to estimate the values of the observations. Then we have to assess. We have to make it deseasonalize your series to free your component from the seasonal wear. So that we have to free the train from the seasonal. These two components we have to free. Then cyclic is basically we have to go for when we go for a long term. Then we have to see the cyclic effect. If sometimes cyclic effect is exists, sometimes seasonal effect is happening. Both may be simultaneously also occur. Once all the things are happening, but then we go for the random component. The random component is the we know the model is already know this is additive model. That means we have to differentiate from the train component and seasonal component to determine the what is the random value of your observations. So random component we have to calculate based on the difference from the series minus seasonal variation minus train variation to get the additive. But if you go for a multiplicative, that is you for the division loop. So that the random component could be analysis based on some certain component, right? What is a mean variability, what is a variation in between the observation. So in many times, what is happening in step 1 to 3, we can always see. And again, if some seasonal effect is there, more seasonal effect exists, then we have to go for deseasonalize your observation. Once your observations or series are deseasonalized, then again we go for a step 1 to see some train again exists or not. So we have to repeat this step 1 to 3 multiple times to free from the train, seasonality and cyclic component. After that, we have to go for the random component. So this is a step we have to follow in decomposition method. If you have any question, you can ask. Anyone having a question? Okay. If you see this example, this is already in the previous example, we can see there's a train is there. So if you see a train component having a pattern like this is a pattern, then it changes, then it go again upward direction. But then the seasonality, whatever pattern it may be there, this type of pattern we can see in the seasonal component. And there's some randomness is also there in between this three. This all three component we have to remove from your original database to make your time series as a stationary series. So one by one we can go when we go for the practical, then we can discuss how we can remove this train component, seasonal component. Now we go for a types of time series data. The first, when we go for Y time series, so we have to discuss the component of time series. Then we go for types of time series data. So types of time series data depend upon the first frequency of observation. What type of frequency? How your observations are recorded. If your observations recorded in a continuous form or your observations are recorded in a discrete form. For example, a wireless device tracks a person heart rate continuously because if continuously they recorded the heart rate, that means every microsecond the device is recorded the information of a particular patient. That means they continuously process, they continuously time series information. But if we go for a discrete time series, where a monthly sales data, that means they recorded what is the every month, what is the sale production in a particular shop, particular business, what is the sale performance is there. That means it always comes under the discrete database. But if we go for a data characteristic, what type of data characteristics is there? Univariate and multivariate, as we discussed in the regression models also, where observations is only depend upon the single variable, we can go for a univariate time series. If observations are depend upon the multiple, then we go for the multiple time series. For example, in a daily temperature, if you only see how your daily temperature is changes, then it's a single variables is there. So we have to go for the univariate time series. If observation of multiple, if we have to consider some another variable which is affected your outcome where temperature and humidity level. Let me analyze this variable together how your temperature changes over the humidity reading as well as vice versa. So there are two components or more than two components we can use to see the data is multivariate or univariate. Then we can go for a pattern, how your data structure is. Your data is stationary or your data is non-stationary. If data is stationary, that means the mean of variance are constant over the time. That means it looks like a white noise. That means it is completely at a random process. In the non-stationary times, that means mean or variance are changes over time. If you see in the stock price market, there is a more fluctuation we can see in the stock price market. That means the trend is changing, seasonal pattern is there, variability is more. So the stock price market is not with a non-stationary. But if you see the white noise process, that means the series is only depend upon the random component. That means the completely randomness. So that this is constant variability is there in this pattern. Then based on the seasonality, already I discussed the seasonal pattern is there. That means if a data having a seasonal observations or data having no seasonal observation, then seasonality we can see. Now we can go for a major component of time series stationarity. What do you mean by stationarity? A time series is said to be stationary if its statistical property like mean, variance, autocorrelations remains constant over time. That means these all are fixed with respect to time. If time is moving towards, there is no change in the mean, no change in the variation, no change in the autocorrelation functions. So this is a very key element of time series. Whenever you have to apply any type of regression model, any type of time series model, we have to first make or find out your series are stationary or not. If your series are not stationary, we have to make this as a stationary. The first type of stationary is strict stationary. A time series is strictly stationary if its distribution does not change over time. That means any set of data points, the joint distribution of observation is same regardless at the time at which the observations are recorded. But if we go for a weak time series, a time series is weak stationary. If its mean and variance are constant, we have to calculate what is the mean of your series, what is the constant, what is the variance of the series for a particular duration of time. Can same is happen for the next duration also? Same is happen for the next duration also. That means we have to identify the lag. For lag one, what is the mean of variance is there? It is same to the lag two also, same to lag three also. So there's a dependency. We can see and calculate the mean and variance to see there is some constant mean and variation happening during this series. So then we can say it is a weak stationary. 1 minute. Testing of stationarity. How we can test the stationarity? But first, testing for stationarity, first we have to see can the data is stationary or not. We have to first making a graph. We have to make a plot. We can make a time series plot and see this having any type of plane effect, any type of seasonal effect. If you see, if you visualize, there is some plane effect is there, there is some seasonal effect is there, then we have to apply some test to verify that your series are stationary or not stationary. There are so many tests are available in literature. Here I discuss the ADF and KPSS test is which is more useful to define your data is stationary or not. The first test is the argumentative diffusion test. This test shows that your null hypothesis is a unit root. Unit root means your outcome, your autoregressive coefficient value is equal to 1. That means there is a no stationarity is exists. But in the alternative says this is a stationary process. Same in the KPSS test also, which shows that time series are stationary around a deterministic train because the KPSS is more useful to when your data having a some train component. Then we have to go for the KPSS test. Once we have to apply this test, then we can see your data is stationary or not. Once you see that your data is non-stationary, then you have to convert into a stationary by doing the decomposition method. Then again check your data is stationary or not. Then if your data is non-stationary, what we do, already discussed, we have to use the decomposition. We have to convert, we have to transform the non-stationary series to a stationary series based on differencing, that means subtracting the previous observation from the current observation, taking a logarithm of the value or seasonal difference or detraining. Already discussed in the decomposition. That means we have to convert your non-stationary series to stationary series based on different type of methodology, type differencing, logging, seasonal difference, and detraining. Once your information, once your data is converted into a stationary, then we have to see what type of relationship exists between the observations. That means we have to calculate the correlation. As we discussed, as already discussed in the regression model, the correlation. Correlation is relationship between the two variable. But here only one variable is there. There is no relationship between the variable. There is some autocorrelation. That means is relationship from the previous observation. That means autocorrelation measures the correlation of a time series between the on past observation. It may relate your previous observation. Some dependency is there. It helps to identify the degree of similarity. What type of similarity is there? There's some common structure is there to see there is a common structure so that we can see there is some relationship so that the outcome should be the significant. Same, it was a partially autocorrelation. Partially autocorrelation measures the correlation after removing the effect of intervening observation. These tools help identify lag structure in the data, critically for selecting appropriate model. For example, we have a monthly sales data over a 5 years. Okay, or this sales data shows that every winter time there is a increase in the sales rate as compared to remaining months. That means every winter vacation. That means there is some significant variable exists from the previous information. So that there is some positive correlation exists. What type of correlation? Every January, every December month having a same relationship from the previous year. But when we go for the positive autocorrelation, what they do, they have to reduce the previous lag correlation. That means they not consider the more information. They not consider the more informations or isolated the effect of previous lag value, and then they may see how much partial autocorrelation function is there between the observations. autocorrelation having a some always having a significant relation between the previous observation, but partial autocorrelation remove the effect of previous lag and show the what is the effect for current lag structure. So he not affected based on the previous information. So there's some comparison between the ACF or PCF because basically we have to discuss it more when we go for models. Now we have to come to the time series, different types of time series models, which is basically used to fit the series into a different type of model. As you discussed, basically in exponential smoothing, moving average are the basic models, which is discussed in the graduation level. But here we have to more towards to the different type of statistical model which having a some random component because the exponential smoothing moving average having no random component, but in every type of data some randomness is exists. So we have to move towards to the different type of time series model. First model is the auto regressive model. In an auto regressive model, the current value of the series is regressed on its previous value. That means there is some relationship is there. If you see in this model, the yt, t is a time period, y is a series. Phi naught, phi 1, and phi 2 are the regression coefficient. That means the auto regressive coefficients are there. So your series, your current observation, for example, today the sale production is depend upon the what is the sale production for previous day, what is the sale performance for previous 2 days, what is sale performance for previous month. So there is some dependency is there from the current information. P is the number of lag value used in the model. That means what is the time period, how much time you can consider, how much lag dependency is there. It is only 2-day dependency, it may be a 5-day dependency, it may be 30-day dependency, we have to see. Then the parameters we have to estimate. We have to estimate the parameter based on different type of estimation technique. Basically, we have to go for a maximal likelihood estimation. Okay, these are the methodology we have to use. Once this is estimated, we have to check the different assumptions like stationarity. Your observations are stationary or not, because whenever we have to apply AR model, we always consider your series are stationary. This is the basic assumptions to apply auto regressive model. For auto regressive model, we have to check the assumptions. Your observations are stationary, observations are lag dependent. If your observations are not lag dependent, we cannot apply the AR model. Then we go for the moving average model. In the moving average model, which the MA model is a type of time series model usually used to forecast and understanding the temporal time effect, because this model is developed based on the random error, that means noise error. This is not depend upon the actual information. This is depend upon the estimated information, like this the error component. What is the error component is there. So your current observation is depend upon the how much randomness is exists between the from current information to previous day, current information to past 2 days, what type of randomness is exists. So we have to develop. This is the model we have to use. So it works when the averaging past data points to smooth your short-term fluctuation and highlight long-term trend. So here, theta naught, theta 1 is the coefficient of the moving average model. Then we go for the auto-regressive moving average model. This is a combine of two element, auto-regressive, moving average. So what is happening in the auto-regressive? Auto-regressive only define your information based on the past observation. This model is completely ignore the randomness between the observations. But when we go for a moving average, what is happening? This having some randomness between the observation, but they not use the actual information. Actual information is also exists, which we have to remove from the information. So this MA having some drawback, AR having drawback. So one model is developed, which is a auto-regressive moving average model, which is a combination of autoregressive and moving average model. So this is the expression for the moving average model. That means theta. This is a component for AR model. This is a component for MA model to make your model as a autoregressive moving average model. Then we go for the autoregressive integrated moving average model. What is happening? Sometimes autoregressive moving average model is applicable when your data is stationary, but sometimes data is not be stationary. It may be unstationary, non-stationary. So what we do, we have to make a difference. We have to remove the seasonal effect. We have to remove the train component. So we have to incorporate the difference to remove the train, seasonality to making the data stationary. So we have to add the integrated. Integrated means there's a difference we have to take on. Maybe the AR we can take on, maybe the MA we can take on. So here the three components are there. One is the autoregressive part, one is the integrated, that means difference between the observations. The third is the moving average part. So basically we have to define based on the ARIMA, PDQ. P is the AR part, Q is the MA part. These are different. How much difference made? So P is the how much lag for AR model, how much lag for the MA model, how much difference you can take to make your series as a stationary. So this is your basic model which is discussed for time series. But sometimes what is happening, this model is not much applicable because this also needs some other variable. This is only depend upon the series. This is also depend upon a different type of explanatory variable. So auto-regressive or integrated moving average model with explanatory variables are there. Some having a seasonal effect. So another model is developed, seasonal auto-regressive integrated moving average model. So depend upon the structure of your database, multiple models are developed to see the nature of your database or which model is perfect fit. Now, what is the step to implement any type of model? What we do first? First, whenever you have to have a database which is related to time series, the first step is to check your data is stationary or not. First, we have to check the data is stationary or not. So we have to apply different type of tests like argumentative ADF test, KPSS test, so to see your data is stationary or not. Or also you can use the autocorrelation function, partial autocorrelation function also to see there is a series are stationary or not. Once we have to see your data is stationary or not, the next step is to making a differencing. If your data is not stationary, that is non-stationary, then you have to take a difference. That means applying the difference to see your data is stationary at how many times you make a difference. The number of times you have to determine the difference to make your series stationary. Once your series is stationary, then you have to determine the what is the dependency for the AR model, what is the dependency for the MA model. It means what is the lag value, how much observations are depend upon the previous observations. So P is always define the dependency between the observations, and Q is define the dependency between the error component. Once you have to determine the what is the P, what is the Q, what is the D, how many D is coming. So P, D, Q is coming. That means you have to easily identify your model. Which model is fitted. That means ARIMA 111 is coming. So fit the ARIMA model. So we have to use different type of software to fit your model. We have to discuss in R how to fit the ARIMA model. Once your model is fitted, then we go for the checking, diagnosis checking. We have to check whether the model is fitted, it is correctly fitted or not, how we can visualize, what is the residual float. So we have to see based on that diagnosis. Then after that, we have to go for the forecasting. My model is best fitted based on the different type of assumption like AIC value, BIC value, AICC. So many model selection criteria is available to find out which model is your best model. Once your best model is identified, then we go for the forecasting or making a forecasted figure which shows in future what is happening or what is not happening. This is the overall structure of time series there. Any question for time series? Then we move to the next topic, which is more reliable in most of the fields because long time series data is very less available. So we have to go over some what is panel data. Well, time series data is the data collected over a time. We have to discuss time series data is collected over a time, but in the cross-sectional data, what is cross-sectional data? Cross-sectional data containing the several information of a variable recorded at the same time point. As discussed in the first case scenario. First case scenario is related to the cross-sectional data, and the second case scenario related to time series. If you have to combine these two informations, time series with cross-sectional data, it comes under the panel data, the pool data, which is a combination of time series data and cross-sectional data. What is panel data? Also known as the longitudinal data. Basically, when we go for in medical, we have to always discuss the longitudinal data. We not say this as a panel data terminology. Basically, they use the longitudinal data analysis. The data set that contain observations over a period of time for the same subject, same individual like country, state, company. Okay, this structure allows researcher to analyze changes over time and to control for unobserved variable that may influence the dependent variable. For example, we have a different countries are there. In the above panel data, what you see here, we have a data set of variable y, x1, x2, x3. These are my outcome variable. X1, x2, x3 are the explanatory variable. So this is a time component, or this is my individual entity. Let's say India, Brazil, China, looks like a country. That means the cross-section information. This is a time series of information. If you combine this, it's a panel data model. When all the entity are observed, if you see for every entity, every country having the information for 2018, 2019, 2020, 2018 and 20. For Brazil also for China. So that means this looks like a balanced panel data. When for every year, for each entity is available, this shows as a balanced data. If, for example, I say Brazil 2020 information are not available, 2018-19 is available. That means for India, 3 years available, for Brazil, 2 years, China, 3 years. That means it looks like a unbalanced panel data. Two types of panel data is available, balanced and unbalanced panel data. So, what is the characteristics? What type of advantage or disadvantage of panel data? As we discussed in the time series data individually analysis. For example, if I apply here the time series data, what the time series model you apply? First, it is applied for India, then apply for Brazil, then apply for China. Individually, they may apply so that there is some heterogeneity is more possibility. There is some heterogeneity is exists between this individual variation. So first is the double dimensionality, because here we have two dimensions. One is the cross-sectional dimension, that means the cross-sectional unit. Second is your time series unit. To increase the ability, your data is more available when we have a two-dimension database. So two-dimensionality may be possible to see the structure of a database. Second is control for individual heterogeneity. When we go for individual database, individual analysis in terms of time series model, there is some more heterogeneity may be possible, which is not be controlled by time series model. So we have to use the panel data model to control the individual heterogeneity. What type of heterogeneity, what type of variability exists over the period of time, which is not be captured in the time series model. But here we can capture the heterogeneity. Third is the multi-level and hierarchical modeling. So when we use the panel data model, we always need a different type of level of analysis. For example, National Family Health Database. National Family Health Database having a multi-level structure. They not go directly to the village. They having a level of structure like state, district, then go for the village, then go for a household. So the multi-level hierarchical structure is there. When we go for a visualization also, we cannot directly go for the village. We have to apply the multi-level hierarchical panel data modeling, so that for every step there is some stratified factor is attached for every level. For example, state level, some stratification level is stratification factor is attached. For again, we go for district level, some stratification factor is available. So multi-level modeling we can easily apply in panel data model. But sometimes it may be disadvantage also because of complexity, very complex. When we go for a multi-level, so many multiple levels, what is happening, sometimes we have to miss. So do not miss any type of level. So if you have to miss, that means there is some complexities exist between the model, which we can little bit affair. But now the technology is improved, so there is no complexity is there. We can easily do this thing. Now attrition. Attrition means sometimes when we go for panel data, so what is happening? So many missing information is mostly observed. So many missing information is there. Non-response rate is as much higher as compared to the individual level. In the individual level, we can easily capture the information. But when we go for a panel data modeling, longitudinal, or we can say a cohort study. Basically, this longitudinal data analysis or panel data modeling is under the cohort study design, where we have to follow up. We have to follow up the information at a multiple time point for multiple individuals. So what is happening? Sometimes the patient participate is stopped due to some reason. So here the more non-response rate is maybe observed. This is one major disadvantage for panel data modeling. So whenever you have to start any type of new study, we have to first focus on different type of structure which reduce your non-response rate and reduce your complexity of your model. Basically, here there are two different type of models are available under the panel. One is a fish effect model. Second is the random effect model. In the fish effect model, control for time invariant characteristics. Random effect with random effect model, assuming that these characteristics are uncorrelated with the predictor. So we have to see how your fixed effect model is affected, the predictor variable as well as your outcome variable. How your random effect model is affected, your outcome and predictor variable changing over the time. So we have to explore the relationship. So we have to see only interested in analysis the impact of variables that are varying over the time. Here we only focus on how your variables are changes over the time. We cannot we completely ignore the within entity variability here because we have to fix. My model is fixed. That means your cross-sectional unit is fixed. We had not be changed. This is only changes based on the time only. So if you see extra relationship between predictor and outcome variable within an entity. So here we have to account the variable that do not change over the time within an entity. We have not changed the individual entity. We only change the time here. So your fixed, what is fixed here? Your cross-sectional unit like country, person, company is fixed. It not be varying with respect to time. For example, male or female, if you go for a world level analysis, in a world level analysis, the structure of male or female, one variable, gender, this never be changed in country to country. For India, India to China, China to Singapore, there is no change in this variable. But if I say age, the age structure little bit changes. So when we go for an age variable, there is changes is happening. So we have to adjust the age. That means we have to standardize your age variable when we go for the country-wise analysis. Similarly, so reduce the bias from the unobserved variables. So this is also important. It may be reduce your bias, whatever bias is available in terms of unobserved variable, because we have to fix your entity. We have to fix your cross-sectional unit. It may control your bias also. This is the assumption of the correlation between the entity error term and the predictor variable. So the time variant characteristics are unique. Here, what is the major focus here? The time variable, how your time is changes. Time is the major factor as compared to your cross-sectional unit, because in the cross-sectional unit, we cannot see what is the variability between the cross-sectional unit, variability between the country. We only see what is the variability within the country, how the country variability changes with respect to the time. So the equation for the fixed effect model is YIT. That means I is denoted the cross-section unit and T is for the time. So here your alpha is your interception, which is depend upon the entity, how much entity is there, and beta is your regression coefficient, dependent coefficient, and error term is there. So T inside if the unobserved value does not change over time, that any change in the dependent variable. This is your dependent variable. Dependent variable, how it may be changes based on the fixed characteristics only. So the interpretation of the beta coefficient would be for a given country, because this estimated beta 1 is only define the estimated value for a particular cross-sectional unit. They may not calculate the estimated value for entire series. They may calculate the estimated value for each or individual unit. So fixed effect model will not work with the data within the cluster. Variation is minimal. So the fixed effect model may be controlled for all time invariance difference between the individual. Now we have to go for the random effect model. The random effect model is also important in panel data because it may consider within entity also and between entity also. Both type of effect it is considered. So there is a random effect is also there. Random effect is in between the entity. So if any reason, so the advantage of random effect is that including time invariant variable in the fixed effect model, those variables are observed by the intercept. So here the what is happening? Your intercept, intercept is here the constant. It not be changed with respect to the entity, because your variation across entity assumed to be random and uncorrelated with the predictor and independent variable. So we have to fix these things also. So in the random effect, you need to specify those individual characteristics that may or may not influence the predictor variable. What we have to see, uncorrelated, which will not be related to your predictor variables. So, but this problems is sometimes more serious when we have a more bias. So, more bias may be possible when we have to use the random effect model. Let's give an example, a study on the effect of new drug of blood pressure. Let's give a case scenario. We have to analyze the effect of a new drug on blood pressure, which is controlled by patient-specific tips like genetics. We have to analyze a new drug and how your new drug is controlling the blood pressure for a particular type of patients. In this study, what is there? We have to control for patient-specific traits. For example, genetics. We can use a one variable genetics, which does not change over the time. This is constant. Genetics never be changed for a particular patient. That it will never be. This is your entity. So how your entity is fixed, but how your change is going on with respect to the time only, not based on the what type of entity it may be. But if you see here, studying the impact of healthcare policy on patient outcomes, assuming hospital specific effect at random. In this, we have to use the random effect model because hospital specific effect, we have to consider multiple hospitals. So multiple hospital having a different type of management. So everyone having a different type of management scenario. So the practice, whatever practice they may follow for every hospital is random. It not be the constant. So between hospital, this is random, but also within hospital, which is hospital also there is a variation with respect to the patient outcomes. So there are two types of variation exist between and within variation. But here we have only within variation. There is no changes in the between variation. So here we can use a fixed effect model. Here we can use a random effect model. Once we have to apply, then we have to go which test, which model we can use. So we have a test is there for to see which model we can use, fixed effect or random. So run a H1 test, decide between the fixed or random effect, where null hypothesis is that the preferred model is a random effect versus the alternative is a fixed effect. It is basically test whether unique errors are correlated with the regression. And the null hypothesis is there are no. So we have first we do what is the steps. First we have to apply the run a fixed effect model, save the estimated value. Then we have to run a random effect model, save the estimated value. Then we have to apply the test to check which model is perfect for a particular database. So this is the basic introduction regarding the time series, what type of different components are available, what is the assumptions of time series, what type of models are available to forecast the present observation in future, in maybe in terms of only time series or in terms of panel data model. If you have any question, you can ask me. Any question? Now we are. Now I'm going to the R, how to run, how to make a time series plot, how to make it easy in your series. These are everywhere for all of us. Run some package which is used for the series, for the time series, for the series. So many packages are running before starting the hour. First, I run all the packages one by one. I get the one thing. But for example, your data is not be in a time series format. How to make your data in a time series format? If I run this, if it, for example, I run a normal random database. This is a database.
Sir, sorry to interrupt. Uh, sir, there is a one question that in a chat box, that is how to decide which model should be used for the time series analysis of the data.
Okay. How to decide which model could be used for time series analysis data? Okay. Whenever you have a database which is related to time series, first we have to see what is the structure of a database. How the structure of it, because right now I have to mostly deal with the model which is having a stationary property. But for example, your time series data is not be stationary. It may be non-stationary database having a non-constant mean and variance. So what should you do? So first we have to check what type of different component you have to visualize, like train, seasonal, or other things. So first we have to identify the different component of time series. Once you have to identify the different component of time series and then remove these different component from the original series, then make your series is stationary. Once your series is stationary, then you have to fit different type of models like AR model, MA model, ARIMA model, ARIMA models. The multiple models are there, but there's a advantage in software. They directly, if you have to directly put the ARIMA models or anything else models, they will give the what is the if it is fit the AR model only, it will fit the MA model only, they fit the AR MA model also. But they also decide based on the AIC value, BIC value, AICC value. This is a basic concept for in statistics, how we can choose which type of model. It's not only for the time series, it is also applicable for regression as discussed by the Seeker and the Vishnu sir, or also in when we go for survival analysis, also when we go for a longitudinal data analysis. So we all are seeing based on the AIC value, BIC value. So based on this, we have to decide which model we can use for a particular database. Are there any mixed meta regression plus time series predicting outcome with patiently interacting at different time point? Yes, there there are multiple variables are available in time series. I'll discuss. I not more discuss in deep in the modeling perspective. I only give the concept what is time series. But if you want to, for example, you say the mixed model regression means what do you mean regression? Regression means the observations are depend upon some explanatory variables. When we have to add it, some explanatory variable also in time series model, because I only discuss the time series model having a observation which is depend upon your previous observation, but we have to include some factors also as discussed why time series. Why time series is the where we have to include some factor. For example, I say stock market price. Stock market price is not only depend upon the previous factor, it is also depend upon some other factors, how the GDP is going towards in the positive, what is the country level structure of the economy. These are the indicators, these are explanatory variable. If you include these explanatory variable into the model, that means it is a mix of regression as well as time series model, which is known as a ARIMAX, auto-regressive integrated moving average model with explanatory variable, because regression is only considered the explanatory variables, predictor variable. This is the basic concept of regression and time series. You combine with explanatory variable, we can add it here. Okay. Can I move to the programming? If you have no question.
Yes, sir. Yes, sir. You can move, sir.
Whenever you have to use any program, we have to first declare what type of data it is. If you're working regression model, there is no need to define, because regression model is sometimes a cross-sectional unit. Independent observations are independent. But when we go for time series modeling, when we go for the panel data modeling, when we go for survey analysis, we have to first declare that your data is a time series format, your data is a survival format, your data is a panel data format. So first, for example, I randomly generated numbers from the normal distribution. Now you have to consider how to make your series as a time series format. So the command for making a series is TS. TS is a command to make series as time series. So TS, my observation is X1. Now you have to define frequency means what is time is there, and it started what year or what days. If you run this, it gives us 360, but that means I have to define my information in terms of days. If I say someone want my data in a quarterly, so you have to define in terms of 4, my data in a quarterly format. From which year to year, we have to mention. For example, it is started from day 1. It is started from second quartile. It started from first month, because it is 12 is coming. Again, it is 1 means year wise. So frequency is year, it is monthly, it is quarterly, it is daily, depend upon the characters. For example, I run 1. Let's see if I run days. So if you see, this is the structure is coming. My data is converted into the time series format. This is a fun step we can use every time. Now I come to the major thing, how we can decentralize this. So I have to use inbuilt database which is already available in R. This is the air passenger database. This is the air passenger database from 1940 to 1949 to 1960. But this gives is what is my objective. First, we have to describe the explanatory data analysis. What is the class? Then we have to do some decomposition methods. We have to plot the time series, test the stationarity, fit the models. We have to go for the calculation of forecasting. So first, we have to check this data. This is my X is a database. Now I have to check if this data is time series format or not. So I define class. 1 minute. So this shows that class is X. That means that my data is converted in a time series form. Where I see what is starting date. This date is a starting date. My data is started in 1949.
Sir, sir, may
Which
you enlarge
yes,
a bit the code so we can easily see it? The console window.
console window. Okay. Now it is okay. Uh, 1 minute. I can do one. Okay, then frequency, tell about the frequency daily, monthly, how your frequency is. So this is a monthly data. Data is recorded in a monthly format. So your data is started from 1949 for January month, and in 1960 for December month. The frequency is monthly. Now, first we have to plot the database. First, the plot is TS plot. TS plot is used to describe your data is a time, how your data is there. If you see how the structure of data for our random generated table, it is this. But I am more deal with this air passenger database. As I discussed in the lecture also, air passenger database is having a some train with some seasonal pattern is there. You see, a pattern is also seasonal. Now this is the first. So same, we can use the plot command. Now we have to go for the what is the ACF and PACF plot. If you plot the ACF, auto correlation for, if you see, I have to plot the air passenger database. If you see, my air passenger database is not looks like a stationary. If you see here, what is you have to observe in the database, there is a variability. Your variance is changed with respect to time. It may be increase the variability. So your data is not be stationary. Your mean is also changed. It not be constant. So mean or variance is not constant. So that your data is non-stationary. Now we can go for, if you see again ACF and PACF plot, what is this blue line? This blue dash line shows the autocorrelation cross value, which shows a 95% confidence interval. It means that specific lag is significantly correlated with current series. So if you see every lag point, this is correlated. But the pattern, if you see here, this is also some looks like a pattern. This is some decreasing pattern for the autocorrelation value. That means there is some relationship exists, but the relationship is not be stationary. It looks like a some non-stationary pattern we can see here. So the ACF shows that the correlation of a time series with lag of its length. Now, if we go for the PACF, in the PACF, what is there? The autocorrelation, because the PACF adjusts the correlation value of previous lag. Only it shows the effect of the current lag only. So the partial autocorrelation is the amount of correlation between a time series and lag of itself. So it is only depend upon the what is the correlation exists based on the particular lag. It is not shows the correlation for all the lags. It may reduce the correlation effect for the previous lag, only shows the correlation here. If you see here, the first, then it is second having some positive correlation. Apart from this, there is no correlation exists between this. So the partial correlation at lag 2 up to 2 is the correlation between the time series. You can see it is second lag. It is not explaining by the first lag. Other lag is not be having a significant correlation value. Now we can go for finding the component of time series. There are different type of components I discuss in the literature. First, I run this command and see what type of different components are there. I can go directly for the plot so that it may be easy to visualize. If you see here, this is my observed series of this database. In this observed series, there is a one train pattern is there, which is we can show here. The second is your seasonal pattern is observed. Everywhere one peak is coming, but the peak is increasing with respect to time. And the third is there some randomness. You see, there is some randomness is there. Randomness is also there in the database. So train, seasonal, randomness is occur. So we have to go one by one to remove this effect. So first we have to go for the train estimation. We have to remove the train. The first step of decomposition is train the estimated value. We have to here what is happening. If you see here, the train value is coming. Two-sided moving average order I have to consider to develop this train component. So we have to calculate the series train by using a moving average method. Here I have to use a moving average method to see the what is train. The order is smoother should be derived from the frequency of the series. You know how to calculate a moving average. Moving average, how do you calculate for a moving example? You have to calculate for moving average for a monthly. So we have to divide it, your series into two. First 6 we have to calculate it. Next 6 observations we calculate, then take an average to get the moving average value for each and every observation. So this is your original series. What is the train is coming? You can easily visualize here. Now I have to remove this train. So I have to use the retraining. Your second step. Second step is your retraining your observation. So I run this command. So this is the original observation. After this, we have to retrain because we have to go for the 6 monthly. So your first 6 observations are missing. Because we have to take an average of first 6 months is come to be here. Then next 6 months is come to be here. To take wise, we have to go for the moving average process. Then we have to remove the train component from your series. Then we have to differentiate from the original series to your train to get the original information. So this is the original information is coming. What is the value, exact value after removing the train component? Now we have to visualize. Now this is the original. This is a training. Now after removing your train from the original series, your structure is towards to the standard stable format. Now there is no train component exists in this database. That means you're free from train. Now we have to go for the seasonal component. In a seasonal component, again, we have to first define what is a month, what is a year, which year you have to consider as a making a train. So we have to use the database for the train variable. Then you have to calculate the seasonal values. If you see here, your seasonal, what type of seasonal pattern is there? For every year, they may report it the what is the seasonal pattern. So if you see, this is the year, this is the month where seasonal pattern is more. Now I have to estimate the seasonal trend, like in the estimating the trend. So we have to calculate the seasonal trend. We have to calculate or estimate the seasonal value. Not coming. Add line. Okay, add line. You can put add line also. Then you see now. Similarly, we have to see in the train component, we have a train, then we have to estimate the train line. Similarly, when we go for a seasonal component, we have to estimate the seasonal train. This is a seasonal pattern is there. This is estimated value of the seasonal pattern. Now we have to differentiate from your estimated for the observed value to getting the deseasonalize your observations. Then we can go for the irregular component. That means your irregularity is coming. So here nothing is there in the irregular. Then the final time series plot after removing your structure, train component, then seasonal is there, then the irregularity is there. As compared to other things. This is all our things are coming for step 1, estimating the train, step 2, retraining, step 2, seasonal, step 4, random component. These are 4 steps we have to discuss in decomposition of your time series data. Now we have to go for the stationarity. For stationarity, direct command is there to find out your series are stationary or no. So here I have to use the argumentative decoupled test, ADF test to see your data is stationary or no. If I run this command, what is the coming is 0.01. That means your data is stationary because your alternative shows that your data is because p-value is less than level of significance. It shows that your data is stationary because already we have to remove the train component, already remove the signal component, so automatically your structure is comes under the stationary process. Then we have to fit the model. We have to directly go for the ARIMA model. ARIMA model automatically fit your AR model, MA model, as well as the integrated model also. So if you see what type of model is fitted for this database, ARIMA 211010. This ARIMA, this first is a PDQ, capital P, capital D, capital Q. There are few things are. This component is for the seasonal. I did not discuss the seasonal auto-regressive integrated moving of average model, but the system, the program is also calculate the seasonal effect also. So if you see the ARIMA 211, that means your observations having a one time difference to make a stationary with having a 2 days dependency leg of P2. That means your model AR model is depend upon the previous 2 observations only, not all the observations. This is only depend upon the previous 2 observations to make the data is one time stationary, difference is stationary one time. MA is 1, that means this is also depend upon the error component, one type difference for the error component because 2 is there. What is difference between the 1 to previous observations, the error we can easily. Here P is not 0, capital D is 0, that means some seasonal effect is also there, which is replaced from differentiating this seasonal your component value. This is a coefficient. This is auto-regressive coefficient values are coming. That means your dependency, your current observation is depend upon 0.5 unit change in your previous value plus 0.2 unit change in your 2 days previous value. And this is the error component is there. If you see here, they also calculate the AIC, AICC and BICC. So these are the major things which is used to select your best model. Which having a less AIC, BIC value, this is a suitable model. Then we have to fit your model. We have to fit your model. That means the fitted command as is used in the regression models also. We have to fit this series. Then we have to forecast and plot the series also. I run all this command and see if this is my original structure is there. Then I have to estimate the series based on suitable model. The model I fitted, this is the model which is fitted here. Based on a fitted model, I have to calculate the fitted values. Once the fitted value is coming, based on fitted value, based on observed series, based on the estimated model, we have to forecast based on this green line. So we have to forecast the observation in future. This is the basic simple models are there. But in the system, they having a multiple things are there. For example, someone asked, can you include the regression? Regression is also included. the command, the terminology, little bit different. You also develop your models also. This is your simple model. When we go for the panel data model, we have to use some package related to panel data. I use one database for rental. This is one database is there for rental database. You see in this rental database having a multiple observations, different cities they were calculated. This database is related to the student, how much student paid for rent. First, we have to apply the fixed effect model where this uh, rent is something referred to the how much rent the students pay. The population. This is a population is there. This is a year. Which year we pay 90 or 90 not. This another variables are there. This is the average income, or this is a population. Population. How much population is there for the particular city? So here we have to define the panel linear model. Then here the index is defined. It means what is your cross section unit? The city is a cross section unit. Or time is your year. So here because we have to go for the fixed effect model, we have defined the width in, which define the fixed effect model. This is summary is coming. If you see here, we have to apply because it shows my data is balanced. If some information are not available, this shows an unbalanced panel. It could go to some summary statistics, then we go for this. Now you can see and visualize how your rent is changes. Your rent is changes. If you see the p-value of this year, it depends upon the time at which you have to go for purchasing or go for rent. Then the what is the income? How much income it may be? The income, population, student, or these all having a positive impact because this go increase your rent price. Your income is high, you can hire a high rented house. Otherwise, you can go for low. But if you go for a fixed effect, same is coming, but here we have defined the random. Same effect is there, but there's some minor changes in the estimated values of the coffee. Now we can choose which model is better. If you see, register Aruskar is also at 94%. Here also almost 95% is there. Both having a perfectly describe your information. Now we have to apply the test, which is better to understand which model I have to consider. If you see value is less than level of 5%, so we have to conclude that your fixed effect model is more suitable because your alternative model is your fixed effect model. Null hypothesis says that here your model is random, but alternative says that your model is fixed. So that we have to conclude your database that we have to apply here the fixed effect model as compared to random effect model. Then you have to making an interpretation for this model based on the fixed effect, how your outcome variable, that is rent price is changes with respect to the income level, with respect to the percentage of population student, with respect to the year of study. From my side, it is over. If you have any question, you can ask. If we have a specific time sheet, then do we have to apply all the models to know this one to use R and then yeah. If you already your data is stationary format, then you can directly apply your model and to compare based on the AIC and BIC value. There is no need to go for the decomposition method if your data is already stationary.
Sumit sir raised the head, sir. Sumit sir, if you have a question, please ask.
Uh, any questions for the audience, participants?
Harsh also raised the hand. Harsh,
Yes.
bhai. One question. Suppose I have monthly purchase for 2 years. What type of analysis I will do?
Yes.
Yes, Dr. Varun, sir.
Sound.
Uh, yes, am I audible?
Yes, you are audible, bhai.
Yeah, Dr. Shekhar, I just raised my hand to say that very good kind of.
So I have monthly
Am I
purchase of
audible?
for
Am I
2 years. What
audible?
type of investment I have to?
Dr.
Yes,
Shekhar,
you
am
are
I
audible.
audible?
Yes, you are audible, bhai.
Yeah, so very good kind of event you have conducted, and I basically gone through the some of the
The
sessions
sound is
from
not.
your also and from Dr. Varun's also. Very
Hello.
informative sessions you have conducted. Thank you for this kind of sessions.
Thank you, bhai. Thank you.
Yes.
Suppose I have monthly purchase for 2 years. What type of analysis I will do? Okay. Uh, if you have a monthly purchase, I have to ask one question. Can you have some other variables also, or you only deal with the one variable, which is the purchase, sale purchase, or something else? So you have to apply simple thing. First, you have to check if data is stationary or not. If your data is stationary, you have to directly apply the regress time series model. If your data is not stationary, you have to go make data is stationary, and you have to go for the time series model. But here only I discuss the one variables only. But in general, in world, this not only depend upon the purchase, previous purchase, it is also depend upon the how many customers are coming, how much amount they spend for this. So some other variables are also there, which may be more important to see the monthly purchase. Wow, what a monthly purchase for in future.
Okay. Anyone else? Okay. All right. So we can sum up it now if no questions are there. Okay. Rahul and Sakshi, over to you.
Uh, yeah. So we'll proceed then. Thank you, Dr. Varun, for such an insightful and engaging session on time series analysis. Your deep expertise and clear explanations have provided us with valuable knowledge and practical skills that will greatly benefit our academic and research work. We truly appreciate the time and effort you have dedicated to this session, and we look forward to applying what we have learned today. Thank you once again for being with us and sharing your expertise. A gentle reminder, tomorrow at the same time, we'll have a session on survival analysis with Dr. Arvind Pandey. The link will be sent in advance. Thank you.
Thank you, everyone. Thank you, sir.
Thank you all participate in the organization to successfully conduct this session. I hope in future also we have a more collaboration and discussion going on. Thank you.
Thank you, sir. Thank you so much.